what I hate. Third act problems. Roll. Stop.
Freeze in digital memory.
And
Activate traveling map. Tony, this better work, pal, or you'll be a digital memory.
Take it easy, Damon. We're loading Richard's image onto the database, and when he's mapped onto the stunt double, you'll never know the difference. All right, boys. Let's see you dance.
Sensational. I love it.
So, well, this is one problem that people are trying to solve, and that is you have an image or a video and you want to fit the 3D model, or just say to know exactly what the volume, what's the shape of the person or object that you're seeing in the video. And if you can figure that out, then you can do many things with it. So you can indeed segment it out from one video, putting it in another video, perhaps animate it, moving in ways it didn't move before, fix the way it appears.
It's more expensive and difficult than it looks, isn't it?
Right, so what's going on here is they're showing people in an editing studio doing something fairly similar to what's done right now in post-production houses, special places like Industrial Light Magic, ILM. The basic idea is that they are building computer models, which we see all the time, computer models for actors. That's things that are used extensively in movies like Star Wars now. But then they're also taking real live footage of somebody who's real and painting them onto this model to make them do something they didn't actually do, right? There's, from what I'm guessing in the clip, is they're trying to fake some sort of an incident that didn't actually occur. And actually, this is relatively close to what is already being done today using advanced computer vision techniques. From this clip, it looks like they just took a single shot of the character played by Arnold Schwarzenegger, and then from that somehow created a full 3D model. That's not very realistic because you'd need to have shots from multiple points of view. But it'd certainly be quite possible using some of the latest techniques to take a movie of the character played by Schwarzenegger and extract different views from different sides and map that onto the 3D model. And the 3D model could even, in a couple of years, be learned automatically from the video.
That's actually close to a lot of things that we do in Star Wars and a lot of the recent effects movies. The problem that you see there is the interaction between the two people. So if they were truly separate, those kind of effects are done all the time, especially if the lighting is not key to the moment, like they're not in a complicated lighting environment. Just reprojecting textures, doing a little bit of lighting on top, it works. It works all the time for face replacement, things like that. The problem you have is when two people interact, you need another level of occlusion detection, a different level of keying, sometimes motion capture to sort of fill in the stuff that you didn't see. And that's an active topic right now of having motion capture on set live so the director can direct two separate performances, maybe one real and one synthetic, interacting. So you can see the fake character and the real character together without having to choreograph two separate timings. If you just take two different motion capture performances done at random, for example, you're going to walk around yourself and stare yourself in the eye, but you have to do it two different times, it will never line up. And that's the problem that you would actually run into if you try to do this for real.
They do rather skate over some evil problems. So I mean, if one just thinks about if I made one, how would I make it? The traveling mat is Furnace Bologna's, but you could figure something out.
What is that?
Traveling mat.
No. What did you call it?
Furnace Bologna's.
Furnace Bologna. Okay, got it.
Damon Runyon. You're an American. You should know Damon Runyon. But the 3D synthesis thing, we might figure out a way to do it. The putting the two together and making the light work right is a real pig of a problem, and it's something. So you can have a bit of fun spotting faked images. So when I taught the graphics course at Berkeley, and then also to some extent when I teach the vision course, I encourage people to read the Weekly World News, which is a supermarket tabloid that has fake pictures in it. And the reason you do that is you get to do a little bit of work on spotting picture faking. Now, a really bad picture faker will get perspective wrong. You know, the guy is the size of a tree, the tree's obviously 6 foot tall, 20 feet tall, you know, there's a problem. Better picture fakers get the geometry right. It's not that difficult to do, but it's very difficult to get the lighting right.
I do agree that perhaps you cannot perhaps you won't be able to reconstruct what was happening in this particular video, but perhaps you will be able to, just by seeing other people under controlled environments, say, given a short video and say, okay, so I can figure out what this person looks like in some under some lighting condition, and now I know what he should look like under other lighting conditions, and you just impose them on the video.
That's true.
So you can trick the viewer.
Yeah. If I see Arnold Schwarzenegger looks like my Uncle Lester, and I have all this data about Uncle Lester, then it's true. Except of course, nobody has an Uncle Lester like that.
I've actually seen similar things by, not as good quality as this, but by the MIT guys, by Greg Shachnarovich. He actually makes people dance together.
Yeah.
It's not this kind of quality, and it still looks a little bit. It doesn't look real, but it's things are going in that direction, I think.
Yeah. So I think currently the problems are the following: that if you were to actually have 3D data, and you can get that by putting some sensors on the person, so like like motion capture equipment, then you could in fact, because you put the people in the same scene and render them and have occlusion worked out correctly, because it's a full 3D model. If you are doing this, but that's really not so easy, given that these people are wrestling and they can't wrestle easily with sensors on top of their bodies.
Oh, they were wrestling. They were not dancing.
If you do it with 2D data, then it's much more challenging, because when you're going to put the two figures together.
But you could do it with multiple cameras. You could do it without motion capture, but still with multiple cameras around.
Yeah,
which is what Greg does.
Yeah, which I suppose is true, but there should be enough features on the body such that you can construct a 3D model.
But what I don't know is whether you can make it look real enough, because when you wrestled, there is some reaction of muscles and so on that, as a result of the pressure that the other person puts, and this is something you cannot fake with these kind of...
The final things that we see in there is that they're actually changing the pose of them. It looks like somehow they're building a three-dimensional model wireframe of them from both of those images. And we can build 3D wireframes of people. It's usually done using laser scanners or structured light techniques. There they had a single image from a single point of view. And we've seen techniques like shape from shading that are able to get you some information based on the diffuse color as it moves across. There's also been some techniques that we've seen where you can put something that's made out of the same material that Steve Seitz was involved in as a sphere, and then do good shape from shading, even if it's something that has specular and diffuse components. But there was clearly no such reference for those shots. And shape from shading still doesn't really get you a full three-dimensional model. It gives you a decent approximation of the front shell of what that shape is. It's clear that they had a better 3D model than that, because when they actually changed the shape of him, they made the two guys even lock arms and start fighting. That gets really difficult, because you're actually deforming the surfaces. You need to have the full 3D geometry. You need to know which parts of the person are hard and which parts are going to squish in more. And when you start deforming, you really need to know how those surfaces reflect light, because you're going to be able to see the glints change around where they are, the shading's going to change a lot, and then getting them to look right at each other like they're in some kind of combat. It's actually changing the faces, the expressions on the faces, and that's one of the most challenging things that we could do today.
So here, no, this is more of this kind of relighting. This is like Paul Debevec stuff, this light stage stuff, where he scans like an actor in this light stage with different lights and different cameras, and then he can put her in a different place by replacing an environment map, putting her in a different environment map. But he needs to know exactly how light coming from different parts from the world affects her skin and hair and all this stuff.
Well, these things may not be the current state of the art. We're not that far, by the way, from these things. I don't think it is that the computer vision field is so far from the things that we saw here.
The FBI has just released security footage of the assassin of Raymond and Eleanor Prentice Shaw entering the hotel 2 hours before the fatal shooting. Authorities have identified the gunman as Klaus Bachmann. Bachmann was believed to have been killed in a car bomb explosion in Chechnya 4 years ago. He was employed there as a covert operations.
I think he picked somebody from his database and then painted him in instead of the original guy.
So first thing is, unlike the two previous clips, here there was not. The two previous clips showed you something which is they tried to relate it to technology to make it seem doable. So like they were putting the mesh on the person, then moving him to the other person, and perhaps that's not the method that would be used, but it makes you feel like okay, there's some technology here, and that's something feasible. Everybody saw at least drawings of 3D meshes, and here it was just erasing him, and there was someone new there.
Yeah.
Like magic.
Magic, yeah.
So it makes it look even
Big
more...
Brother.
Yeah.
Yeah. It's kind of scary, but we can kind of almost do something like that. Yeah.
So you can also just split it into two tasks. First one would be just let's cut out that first person from the video, and in Paint, and then perhaps Alyosha can talk about that. Here's a piece of work he's done about in painting, filling in, and you don't need it to be perfect because you're going then to plant in another person. The only problem is that this other person, you need to have him in the correct viewpoint, in the correct illumination. Again, the same problems we talked about in the previous video.
Right.
So some sort of synthesis. You're going to put it. It's not just a single image. This is a video, so you have 30 frames per second, and you need lots of those images, lots of positions, expressions. You need the movement to look natural. So that part is missing.
So what the stuff that we did was a little toy example. One of my office mates, he's a Canadian, and he wanted to be in the World Cup, right? In the soccer World Cup, which Canada doesn't really do very well in the World Cup. And we decided if we take enough video of this guy Greg running around, and then we have this database of Gregs doing various things, and then we can try to, from the database, find the right frames to put in a video from the World Cup, pick a player, some German guy, and put Greg in instead of the player, and it kind of worked. We have Greg running around, and he can score goals right now, but and you can really see the outline. So it's really, the lighting issues are definitely a problem. You have to really again match the lighting, matching the action. It's kind of, if you have enough data of the person you want to in Paint, then it's okay. But the issue of the lighting and the occlusions that the running people in front of the person that is being painted, like in that video. I think another interesting thing is of course there is some issues here where people say, how could you do this? This is you're changing. You're changing a document, you're changing this archival footage and putting new pixels inside. But my response to this has always been, you shouldn't trust photography or video in the first place. For example, here you're watching TV, right? And you basically see in a box 2 talking heads, right? We don't have any torsos. We don't have any bodies. We're 2 heads in a TV box. There is absolutely nothing natural or truthful about this, right? And our colors are skin color is probably completely wrong on the other side of the TV, and probably a host of other things are just not true, and people take it for granted because, well, that's the technology. But really, we shouldn't trust it to begin with, and fiddling with it a little bit more. Well, it just technology improves somewhere, no?
In the current day and age, you should never believe any video that you see. I mean, the technology has gotten good enough for synthesizing things that look completely realistic that never existed in the physical world. And that's a big change in over the last decade, but even in the last 2 or 3 years, there's been a lot of change. And that if you look at when a movie like that was made, you would have needed millions of dollars to synthesize something that didn't happen in the real world, and now anybody can do it on their desktop. They may not be able to do it quite as smoothly as Hollywood can, but and so, out of that, we're seeing things like whole changes in the way advertising works, where you get product placements. You can just insert your favorite, brand of soda into the television program and so forth. And it just, the whole notion, and I think that video or photographs show you anything about the real world is one that it's really no longer true going forward. And we can thank computer vision for that, because if you couldn't analyze the image and video data in order to insert things into those images, you wouldn't be able to do that.
So, well, I'm not sure what to say more.
Yeah.
You summarized it pretty well.
Yeah.
So all the things that we saw here were not far-fetched. This is not science fiction. Things are, if you have really nice person wearing yellow clothes and you have a blue background, you can very easily cut out that person from that video and then put that person in wherever you want. That makes your life easy.
But if you have a blue shirt, then blue background will not do anything for you. Yes.
Right, and it's very easy to see. Lots of times there, those people who do the weather on TV, sometimes like there are holes in their clothes or their eyes disappear. You can't have blue. If you want to do the weather report, you can't have blue eyes. That's a requirement for this job.
Yeah, I mean the fact that it's real time, we cannot do things real time. Definitely not. But on the other hand, I'm not sure that this is such a big issue, because if nothing else, we just wait a few years, maybe decades, and the computers are going to catch up. So the speed is not an issue. I think the issue is that in the movies they always show you things working perfectly. They never show you things not working, and we see a lot of times when things are not working.
Yes.
Unfortunately.
Yes.
But that's also the fun part of it, I guess.